Good morning, one and all. I'm Pitanushree, user scholar on the Department of Tribly from Lendi Institution of Engineering and Technology, Andhra Pradesh, and I was here to present a paper on integration of electrical vehicles in smart grid, an overview. My presentation is all about 10 minutes, and I was going to discuss the following topics starting with the abstract and introduction, some important topics, and I conclude it. Abstract. Nowadays, due to some environmental issues, our world has started adopting electrical vehicles as an alternative transport option. So, recently, the development of smart grid leads to the power grid. So, by using this technology, we can move the power from vehicle to grid technology, and it is used as vehicle to grid, vehicle to home, and vehicle to vehicle technology. So, by using this, we can give the power or energy from grid vehicles to grid also. So, by using this, we can say that the power grid regulation it is to adjust the output to meet demand, and the spinning reserve it is the capacity storage which we can uh, compensate for generators or transmission outages within 10 minutes, and in load leveling we can reach the demand, and by reactive power compensation we can attain voltage control, and by using these technologies we can use the vehicle to grid technology. Introduction. Nowadays the fossil fuels are decreasing day by day. Within 50 years the petroleum and other oils are exhausting. So to decrease that, the world is viewing for the other sources like renewable energy sources. So by using renewable energy sources we can decrease our needs. So nowadays the main problem is transportation. In transportation, we are using the fossil fuels, but in future there is no fossil fuel, so we can adopt the electrical vehicles. So in electrical vehicles it is an zero exhaust gases it releases, so we do not have any carbon dioxide emissions, or it is very gives less noise pollution, and it acts as a storage system. uh, for us the renewable we can produce energy from renewable energy sources, but we have no capacity storages to store that energy. So by using that renewable energy sources and electrical vehicles we can store the energy in the morning times, and we can use it in the night times also. So we have flexible, and EVs can be flexible also by using vehicle to grid, vehicle to home, and vehicle to vehicle technologies. The electrical vehicles has become more competitive when compared to the other sources, and it is for this we have to use the charging capacities, and it is mainly used for the power utility. By using this we can give the energy from vehicle to grid also. In vehicle to grid technology, we give energy from vehicle to grid also in the peak load timing. And by using the electrical vehicles, we can give the energy. So by using the uh, bidirectional and electrical vehicle charging stations, as shown in the figure, the power grid, there is a converter, AC or DC converter. The maximum amount of the electrical vehicles are charged by using the DC connector, and the most of the power stations are AC. So we use the converters from AC to DC or DC to AC. So it involves the some important topics like power utility system, which is a system. It is a group of generation, transmission, distribution, and communication, and other facilities that are physically connected. And we use aggregator, and we use the bidirectional battery charging facilities, etc. And there is a communication between the vehicles and power grid. Bidirectional vehicle to grid technology. In this, we use the electrical vehicle battery from DC to AC converters as shown in the figure. At a time, we can both charge the electrical vehicle, and we can give the electrical vehicle energy from to the grid. and we can create our own power sources, and it has a buffering storage and supply to solve issues of renewable energy sources. And we can store the energy in electrical vehicles in the demand, something like when there is an emergency like hurricanes or any other situations, we can give the electrical power from electrical vehicles to our home. In vehicle to grid technology, there is both advantages and challenges. The most of the advantages are ancillary services. In the services, the power is used from the generators to consumers easily, and to achieve peak loading, it is used to smooth the peak load curves. And in the load leveling, we can store the energy in light loading demand, and we can give it in the maximum demand time. In the main challenges are economical, technical, and social challenges. It is the main challenges are in the local and regional and national energy need. So to reduce these challenges, we have to uh, make the electrical vehicles irrespective of the temperature, climate, and many other aspects like road facilities and the country regional area. So we have to design our electrical vehicle uh, according to and irrespective of these aspects, and we can reduce these challenges by adopting our new technologies. And for the electrical vehicles, we can use the smart battery management systems. So in this vehicle to grid technology, we can give this uh, energy from vehicle to grid also. Conclusion. In this paper, I mainly discussed about the electrical vehicle to grid technology. And in vehicle to grid technology, we can give the power from vehicle to grid also. So it is of two types, in unidirectional and bidirectional. In unidirectional, the power is transmitted from grid to vehicle only, but in bidirectional, the power is transmitted from vehicle to grid and also grid to vehicle also. So by using this, we can provide the numerical services like ancillary services, peak load saving and load leveling, etc. Like I said earlier. So in this vehicle to grid technologies, we can make our life much more easier. So in this electrical vehicle charging station network with bidirectional community communication infrastructure is needed. So by using this technology, we can make our life much more easier and much more sustainable. So as the renewable energy sources are, we are depending on it, and the fossil fuels are decreasing. By adopting this new technology, we can sustain our life more easily and happily. The future scope. In our future scope, the vehicle to grid technology is most probably common, and it is our future in within the 40 or 50 years. So, as shown in the figure, from vehicle to grid technologies, we get the DC energy from renewable sources. By using the converter, we can convert it into DC to AC. We can give it to our houses and our electrical vehicles and grid also. So it is available to support grid. Whenever there is a need of energy, we can use the energy sources and we can provide energy. So it is used to balance the electrical demand. So balancing our demand is much more important to sustain our future life. So it is used, and the smooth consumption spikes, and it is used for by using the electrical vehicle batteries. So for the better batteries, we have to use the battery management system also. And my main references are these sources, and I have mentioned my references in my paper. And thank you.